Good morning. I'm going to start with a quick survey. I can barely see, but I have in my hand here an Amazon Echo Dot. This is the small version of the Amazon Echo. It's in the US, it sells for about $49. It's about 49 euros in Germany, and it's also available in the United Kingdom. How many of you have actually used an Amazon Echo? Maybe a quarter of you. That's probably about right for an audience where the product isn't generally available across all countries, although it will be at some point. I work at Amazon on the part of Amazon Alexa called Smart Home. Amazon Alexa is the cloud service that provides the personal agent for Amazon Echo. And that cloud service powers not only the Amazon Echo class of devices, but a whole set of devices from other device manufacturers, ranging from smartwatches to automobiles, smart refrigerators, robotic vacuum cleaners, and so forth. And my job at Amazon is to help Alexa be able to interact with the physical world. And that's what we mean by smart home. I'll give you a couple examples of what I can do in my own home. When it's time to go to bed and the TV in the kitchen is still on, it used to be that my wife would have to go and scrounge around and find that remote control that had fallen down into the cushions in the chair or was across the room somewhere. She'd have to find it and turn the TV off. And now she can simply say, "Alexa, turn off the kitchen TV." Or anytime the house is not to her liking from a temperature perspective, she can say, "Alexa, make it warmer in here." And it will interact with her thermostat and turn up the temperature. And so what we're doing with Smart Home is we're enabling this cloud-based intelligent service that uses voice technology to create the most natural user interface for interaction, voice, to interact with your physical environment. So my name is Charlie Kindel. And as I said, I run this, I'm going to set this here so I don't forget it. I run the Smart Home team at Amazon. And when I was asked to give this presentation, the theme was to project, what I think is going to happen in the year 2027, 10 years from now. And I'm not pretty good at predicting the future. But I can see trends and patterns from history. And so the theme of my talk today is to talk a little bit about what we see at Amazon in terms of the history of technology and what we see is happening centered around machine learning, voice user interfaces, and the concept of natural human interface. For hundreds of thousands of years, roughly about 100,000 years, humans have been interacting with each other using communication. It was about that long ago when we started actually communicating with each other, where we were able to use voice and written word to interact. If you think about the computer industry and interactive computers for the last, 40, 50 years, we've really only interacted with computers using our fingers, our eyes, and our ears. We've used keyboards, mice, screens, a little bit of sound with sound cards in PCs, but we really haven't interacted with computers the way we interact with each other as humans. This idea of interacting in really natural ways is not new. We've been talking about things like speech recognition for a long time. When I was in high school in 1984 in Southern California, for my senior project in school, built a voice-operated voting system for the school. The idea was for the 1984 US presidential election to allow the kids in the school to do a mock vote. And with my little system that I built on an Apple II computer and a sound card that supported 64 words that it could recognize, I built this system so students could vote for either Walter Mondale or Ronald Reagan. Now, it sort of worked. But the thing that I remember most around that was thinking to myself, wow, speech recognition is just around the corner. And that was 1984. Humans communicate using all of our actuators and sensors. What do I mean by that? When I'm up here talking, I am using my vocal cords to actuate sound energy so you can hear me. I'm using my arm muscles to actuate my hands so I can gesticulate, because that's part of me communicating. My facial muscles to show my expression. I'm also putting off pheromones. I have actuators in my body that are generating pheromones. And I'm a little nervous, and so those pheromones are allowing you near in the front, most likely. You actually are smelling me right now. And that's part of the way we communicate. The converse of actuators are our sensors. You hear me right now, you're hearing my words, you're seeing my gesticulations, you're smelling me. I have a sense of balance, so I know I'm not about to fall over. I have all sorts of senses, sense of time, etc. And you have to ask yourself the question are the simple ways that we've used to communicate with each other with computers for the last 40 or 50 years, using just our fingers, our eyes, and our ears, is that really the best way? Wouldn't it be great if we could interact with technology with the same ease and high bandwidth that we can with each other? And so that's the vision of natural human interfaces. And it's the vision that has come true with products like Amazon Echo and Amazon Alexa. Let's talk about step functions and inflection points. In the 70s and the 80s, computing was centered around character mode interfaces. You had these terminals and you type into and you see characters on the screen. There were really no graphics. And if there were graphics, it was hard to really see what you were looking at. In the 80s, with things like Microsoft Windows and the Macintosh, there was a major step function that occurred in computing technology. That step function occurred because there was an inflection point around the availability of low-cost graphics for PCs, the invention of the mouse, a suitable number of applications that actually took advantage of the platforms that had graphical user interfaces. All of these things came together as an inflection point which caused this step function. And that step function created massive value. Brand new companies and empires were created. And hundreds of millions of more individuals on our planet had access to technology as a result and could use computers. The same thing happened with the advent of the World Wide Web and the internet. There was a whole inflection point of things came together around web browsers and a number of websites that came to be standards around being able to exchange data using HTML and HTTP, all of those things. That was an inflection point that led to another massive step function which created massive new value, great opportunities, and enabled more and more customers to have access to technology. It happened again. Who knows that today is the 10th anniversary of the day that the iPhone went on sale? 2007. That point in time represents probably the best inflection point around mobile. It wasn't the beginning of mobile, but a bunch of things came together when Apple released the iPhone that enabled a huge step function, again in computing. We're now at the point where pretty much everybody has a mobile device. And we walk around them within our pockets all the time. It's just part of our life. And so the question we ask is, today in 2017 and moving into 2027, what's that next step function? And I really, really believe it's around this concept of natural human interface. The ability to interact with computers using the same techniques we use with each other. Voice is the best example. And we're at that point in time today where we really know it's happening. How do we know? The primary way we know at Amazon is customers are telling us. We've built this product around Amazon Echo and Alexa that is selling extremely well. And we can't even make enough of them. And customers are using it. The usage numbers are off the charts, and they love it. The video I'm about to show you is a little video that was composed of videos that customers sent us showing us how they use Amazon Echo in their smart homes.
Alexa, kitchen TV on.
Okay.
Alexa, open Sylvia's garage door. Yes, I named my car Sylvia.
Turn off the living room windows.
Alexa, I'm cold.
Your Nest is now set to 84.
Alexa, turn on the holiday spirit.
Okay.
Turn on pool deck lights.
Turn on garden lights.
Turn on office fan.
Alexa, turn on coffee maker.
Alexa, ask my house to turn on the vacuum cleaner.
Alexa, pitch ball.
Mix me a Negroni.
Alexa, satellite off.
Bam.
So we're now at this point where we can interact with computers using very natural voice. To get to that point, there had to be a lot of invention. And Amazon, to do this, we had to invent all sorts of things. We had to invent microphone arrays and microphone technology with beamforming that enables a device like the Echo to hear voices even in a really noisy room. We had to invent new techniques for machine learning. By the way, the machine learning, a big part of our machine learning effort is in Berlin. We had to invent technology around machine intelligence for being able to answer questions, any question a customer asks. The part of Amazon Alexa group that does all of our question and answering stuff is in Cambridge, United Kingdom. We had to invent technology for having natural speech. So when you talk to Alexa and she answers back, she talks to you in a very natural language, voice. And that voice, by the way, is tuned for each country that it's available in. So the voice in Germany is very different from the voice that you hear in the United Kingdom or in the US. And the team that builds all of that is in Gdansk, Poland. We also had to invent technologies and techniques to ensure customer trust. We had to invent privacy mechanisms to ensure that customers' privacy was protected with the device. And so as we move into the next phase and we think about this point where we're clearly at an inflection point in technology, we're at the beginning of a step function. We use the term day one. It's only day one. Even though Echo has been on the market in the US since 2014, our view is this is just day one. We're just getting started and the industry's just getting started. And there's all this other evidence that shows that we're at one of these inflection points. Machine intelligence, for example. There's a game called Go. You've probably heard. It's a very famous board game called Go. And there's world champions who are just phenomenal at playing this game. And for years, the artificial intelligence community has been trying to build technology to beat the best players. About 2 years ago, they all said, it's going to be another 10 years. It'll be easily another 10 years before we think we can beat the best human players. Well, earlier this year, computers beat the best human player. We see the advances in autonomous driving. Another example of machine learning and machine intelligence accelerating to the point where these solutions are very real today. And so I'll end my talk by talking about how you, whether you're work for a small company in England and you build robots, or whether you represent a government, whether you're in industry, or you're just a parent, or you're starting a company, how you can be thinking about how you can put yourself in a position today to be riding the next wave of innovation and working on technologies and customer solutions that are centered on the concept of natural human interaction. Because my belief is that in 2027, the way that we interact with computers is going to be a lot like the way we interact with people, each other today. So with that, thank you very much. Enjoy the rest of the show.